In this activity, we will use transects and subplots or quadrats to collect data. Placing sampling frames along a series of transects allows us to get an accurate picture of a smaller but distributed portion of a site. This is easier than trying to find and collect data for every plant on the site, especially for large sites. We use a PVC plant sampling frame measuring 1/2 meter by 1 meter as pictured here. These PVC frames are used to create subplots or quadrats, and in Activity 1 we place the subplots every 5 meters along transects, starting at the 0 meter mark. You will sample milkweed and blooming plants within 100 subplots at your site. This may sound like a lot, but remember that not all sites will contain a lot of milkweed or blooming plant species, and not all subplots will have the same number or diversity of plants. Data recording goes quickly in sparse sites, but may take a bit longer in highly diverse ones. The subplot is divided into 3 visual sections. We use brightly colored tape to mark the midsection of the plant sampling frame, as you can see in orange here. This divides the plot into 2 sections, A and B. The third section, C, is formed by flipping the subplot over the transect line. Here's an example of what that looks like as you sample subplots along every 5 meters on the transect. As we mentioned earlier, you will record both milkweed and blooming plants within the subplot, but we will first start with learning about how to record blooming plants. The IMMP has 2 options for collecting blooming plant information. If you feel comfortable identifying most blooming plants to the species level, or would like to use a guide to learn ones you are less familiar with, you should choose option A. In option A, you will identify all or most of the blooming plants to the species level within each subplot. If you do not want to identify species, you should choose option B. In this option, you will simply record the presence or absence of any flower within the subplot frame. This information is still very valuable to the project and may be best for some participants. Over time, if you learn the species that grow at your site, you can change to option A at a later date. This is an example of what it looks like as you're placing subplots along the transect line out in the field. It works well to have 2 people to conduct this activity. One person can place the frame and look for milkweed and blooming plants within the subplot, while the other records the data that the other person calls out. Within the subplot, we will be recording the section in which we first observe each species in every subplot. When you place your subplot down on the left side of the transect, you will first look in section A of the subplot. Record any plant species you observe currently in bloom on your datasheet. Then you will shift your eyes to section B and record any new plant species you see blooming, those that were not yet observed in section A. Next, flip the frame over to the right side of the transect, forming section C. Again, record any new blooming species that have not yet been recorded in sections A or B. If no blooming species are observed in the subplot, draw a line through the column so that you can keep track of the subplots with zeros. In this example, we'll start by looking at subplot number 1 in section A. We've first searched section A for blooming plants, and we found dandelion blooming in section A. On our data sheet, we'll look in the column that says Blooming Plants and write in Dandelion. Then we'll move to subplot number 1 and write the section in which we saw dandelion blooming first. We don't see anything blooming in any other plant blooming in section A, so we move to section B. Now we see that we have purple coneflower blooming in section B, so we make another row on the datasheet for purple coneflower. We are still within subplot 1, so under the subplot 1 column we will write a B. Next we'll flip the frame and look in section C, and we find that we've already recorded dandelion in section A, so we move on to subplot number 2. In subplot number 2, we first look in section A and find that we have blooming butterfly weed. We make another row for blooming butterfly weed and mark that we saw it in subplot number 2 in section A. We don't see any other plant species in A, so we move to section B. Now we find that we have blooming common milkweed in section B, so we make another row for common milkweed, and we record a B under subplot number 2. Then we flip the frame and form section C, and record that we have dandelion blooming in section C. This has not yet been recorded in A or B. We can move to the row that says dandelion on our datasheet and under subplot number 2 write in a C. Now we've moved to subplot number 3. We first search section A for blooming plants and we don't see anything within section A. Then we shift our eyes to B. We still don't see any blooming plants in B. Then we flip to section C, and yet we still don't see anything blooming in C. Thus, to keep track of which subplots contain zeros or nothing in them, it's easiest to draw a line down through the column so that you don't accidentally write in data from the next subplot in the empty column. Now, for those who participate in option B, we'll walk through a similar example. In subplot number 1, we'd first look in section A. We see dandelion blooming in section A, so ignoring the species here, we write an A under subplot number 1. We're simply recording whether there's anything blooming in section A, B, or C. Since we did have something blooming in A, we can ignore sections B and C and move on to subplot number 2. In subplot number 2, we look in section A. We don't see anything blooming in A, so we shift our eyes to B and notice there's a blooming plant in section B. So under subplot number 2, we record a B. Since we've already recorded something now for this subplot, we can move to subplot number 3. In subplot number 3, we don't find anything blooming in A, B, or C, so similarly to option A, we would draw a line down the column for subplot number 3. Now we're going to talk about how to record milkweed within the subplots. Before moving to your next subplot, but after recording blooming plants, record milkweed plant data within the subplot. On the bottom half of your datasheet, below where you'll record blooming plants, record each species of milkweed observed in the entire subplot, sections A, B, and C combined. Do not list them separately by section like you did for the blooming plants. Only record plants that are rooted within the sampling frame. If you encounter blooming milkweed, make sure to record it twice, once in the blooming plant section and once in the milkweed section. If you observed it but it is not in bloom, only record it in the milkweed section. For each species of milkweed observed, count the number of plants. If the plant is not common milkweed or world milkweed, also count the number of stems. common and whorled milkweed are excluded from the stem count because they primarily grow as single stems. Again, record the plant only if it is rooted within the sampling frame, and count the number of stems associated with the plant. Butterfly weed or Asclepias tuberosa plants often have multiple stems. The stems originate from a central location in the soil as pictured here. In this case, we would count the butterfly weed as one plant with multiple stems. Here is an example of a multi-stemmed tuberosa plant. In this case, it would be one plant with 4 stems. Now we'll go through an example of how to record milkweed on your datasheet. Starting with subplot number 2, we would count the milkweed by species that occur in the subplot. For example, we see that we have butterfly weed growing, and we have 2 plants with 1 stem each. On the bottom part of our datasheet, we would write in subplot number 2, butterfly weed, 2 plants, and since they have 1 stem each, we'd write in 2 stems. You'll notice that we also have common milkweed, so we'll write in again for subplot number 2, but a new species, common milkweed, and we have 1 plant, and we can ignore the 1 stem there, since we know that common milkweed grows as a single stem. If milkweed is very sparse at your site, you have the option of recording milkweed between subplots in addition to recording those within. This increases the chance that you will encounter milkweeds in your survey by increasing the area you are surveying for milkweed. This technique can be effective for sites where milkweed is present but not detected in the regular subplot sampling. It is important to note on your datasheet in the upper right-hand corner whether you monitored milkweed along the entire transects or just within subplots. If you're monitoring between subplots as well, label these between subplot milkweeds as the subplot number plus 0.5. For example, milkweeds between subplots 1 and 2 would be labeled as 1.5 in the subplot number column. Some plants may have multiple common names and/or scientific names listed in field guides and on websites. The IMMP uses data from USDA Plants database to track them. If using paper data forms, you may either record the common or scientific name, as these are linked together in the data entry system. If you do not find the name you are looking for, check the USDA Plants database in case the name has been changed. Additionally, if there is a plant that is really difficult to determine by species, it is okay to record by genus. In the Midwest, Solidago or goldenrod is a good example of this. There are multiple species that are very hard to distinguish between. In that case, you could write Solidago species in the species row for that plant. In the data entry system, there is also a category for unknowns. If there is a plant you can absolutely not identify, you can record this as an unknown, and there is an option to record or upload a picture of it. If monarchs of any stage are observed outside the described activities, record them as miscellaneous monarch observations. Also record the behavior of these. These include flying through the site, flying high over the site, which is greater than 5 meters high, resting, which includes roosting, ovipositing or laying eggs, mating, and nectaring. If nectaring, record the associated plant species. If ovipositing, record the milkweed species on which the monarch is laying eggs. For egg, larva, or pupa observations, simply record the number observed in the plot as well as the instar of the larvae. You can see Appendix E for behavior definitions and information on how to distinguish among them. This is an example of where you would record that information on your datasheet. On the last page of your Activity 1 datasheet set, there is a box for miscellaneous monarch observations. After completing the subplot sampling, walk throughout the monitoring plot to record any additional blooming plant or milkweed species that were not observed within the subplots as additional plant species. Walk throughout the plot to ensure as much coverage as possible. You may also record these species as you see them while monitoring subplots. As you did within subplots, make sure to record blooming milkweed twice, once in the blooming plant section and once in the milkweed section. If you observed milkweed but it is not in bloom, you'll only record it in the milkweed section. Thank you for completing the Activity 1 online training video. We invite you to complete the Activity 1 practice activity to become more familiar with recording data. You can find all training materials at the website shown here, or you may contact Monarch Joint Venture staff with specific questions at the email address listed below. Thank you and happy monitoring!